Hi, everyone. Thank you for having me. My name is Joey Gonzalez, and today I want to talk about some of my research at UC Berkeley. And in particular, I'm going to do that through the lens of making some forecasts for the field of generative AI. So as I said, my name is Joey Gonzalez. I'm a professor at UC Berkeley. I'm one of the co-directors of the Sky Computing Lab. I helped launch the LM-SIS project. I co-founded RunLLM and Turi, so some experience in working with industrial applications of AI. I do research in AI and data systems. I also teach the big data science and AI classes at UC Berkeley. So we have a lot of interaction with students as well. So as I said, today I want to talk about my research. We're going to do that by looking at where things are headed. So I'm going to make some predictions for 2025, well, maybe the end of 2024 at least. I have a blog that actually has a lot more predictions and thoughts on both the evolution of the technology as well as the industry of generative AI. But for this blog, for this talk, I want to focus on three predictions. So first, conversational evaluation. I believe we're going to move beyond the traditional benchmarks to evaluate AI alignment in real-world settings, and I'll talk more about that. The use of synthetic data augmentation. I believe we will use LLMs to curate data sets for fine-tuning, LLMs for specific knowledge and behaviors, and that a big part of how we build the next generation of LLM technology be really around synthetic data augmentation. And then I want to talk about context management systems. This is an emerging class of systems that will manage the context that we feed into our LLMs to improve quality, unlock agentic reasoning, and really ultimately are a key part of the successful application of generative AI. And I want to wrap up at the very end by giving sort of my view of two emerging fields of AI that we see coming out of research, and I think people should be following as the field evolves. So let's start with the age of conversational evaluation. So the key point here is that human alignment is more than being correct. We got into the world of evaluating large language models when we launched the Vicuna series of models back in 2023. So this was a friendly competition between some colleagues at Stanford, where we were developing open source chat following models, so instruction fine-tuned models. And we had a new model, Vicuna, that we thought was better. But how do you show that it's better? Just using existing benchmarks, we weren't seeing significant differentiation. So we wanted a better way to evaluate models. So we thought about looking at more open-ended tasks. So something like compose an engaging travel blog post about a recent trip to Hawaii, highlight cultural experiences and must-see attractions. There is no right answer to that, but we can give that task to multiple LLMs, and then we can ask another LLM, here GPT-4, to evaluate the responses. We can give it a rubric, much like we would give to a TA reviewing an essay. We can also have it compare the quality of the two responses with respect to different dimensions. So this idea was codified in the MT Bench paper, the multi-turn benchmark. This idea is the LLM as a judge, and this is a pretty powerful idea. So in this work, we studied the use of GPT-4 as a judge, evaluated it against human experts. Interestingly, GPT-4 agrees with humans more than humans agree with each other. And in fact, if you ask a human, would you like to change your answer? Here's an alternative explanation. They'll often switch to what GPT-4 says. So it's pretty good as a judge. We looked at multi-turn questions. The MT means multi-turn. So this isn't just write a travel blog, but then explain why this was engaging. So having follow-up questions. We did this analysis organized around different topic areas to see differentiation across those different areas. And we found that this approach really provides strong separation of models. It could show that the Vicuna model was better than our colleagues at Stanford. But more importantly, it will allow us to compare a broad range of open source and commercial models. In the process of doing this, we also came across some pretty exciting biases. It will kind of form the foundation of what I think will be a new field of AI in the future. This idea that, as we ask GPT-4 to judge things, that it prefers the first thing it sees. It has an ordering bias. It also has a self-preference bias. So it prefers documents it wrote or responses it authored over other responses. The core hypothesis that makes this work and many of the prompting techniques in use today is that it is easier to critique than to create. And so that is why we can use a panel of weaker judges, evaluate open-ended tasks, and actually evaluate complex models. Because again, simple models can evaluate these complex things because it really is easier to critique than to create. In addition to the kind of automated evaluation of LLMs, we also had launched with the Vicuna models a web interface to let you chat with the Vicuna models, the Stanford models, and some of the commercial models at that point in time. And in doing that, we thought, it'd be fun if maybe you could chat with a random pair of models and you could give a vote on which one chatted better. And here you're going to have an open-ended conversation about whatever you want, a multi-round conversation with 2 models at once. And you can go there today and try it now. So it was a very simple setup. We launched it as more of a kind of a whim. Let's see what happens. We got a fair number of votes early on. We took these paired conversations, we called them battles, and computed ELO scores and eventually Bradley-Terry coefficients for each of the models. And that lets us build a ranking on the human evaluation of these models for a broad range of both commercial and open source models. So here you can see the ranking, the latest ranking of some of the models here. Like GPT's 01 is quite impressive. You'll notice we have these confidence intervals. These are estimated using the bootstrap. So we have some sense of, the 01 is good, but it's pretty comparable maybe to GPT 4.0 in general in terms of human preference. You can see who's kind of first, who's second, and we see a long list of models that are actually pretty close. And one of the exciting things for me in looking at this data is the open source models are actually coming a long way. A while ago, I had hypothesized that the open source models wouldn't really ever be able to catch up because of the costs of training. But fortunately, companies like Meta are willing to put the money in to build big open source models that are competitive with state-of-the-art commercial models. So we're seeing really neat results in the arena. We've also found that just like with the MTA bench that, you can break down the results by different areas and you see different rankings. So you look at coding versus mathematical reasoning versus various languages, you see the order of models can change quite significantly. And so the best model really can depend on the situation. We've been lucky enough to have a pretty successful project, which has generated interest both in academia and in industry. And many of the model developers and the big AI kind of influencers have started to look at this as a good source of information, at least to get a general sense of how models rank. There's an important caveat that some people miss when they think about the arena, is that we're really just measuring human preference. Chatbot Arena is open conversations. There may be clear objectives, but there may not exactly be a right answer. And when there is, the human judge isn't necessarily a good judge of whether or not it was right. So it's really human preference. And then, of course, as I said earlier, it could be very context dependent. And so depending on the kinds of tasks that people are doing, let's say coding, we see different rankings. One of the other things that came out of this research that's been pretty neat is we're starting to see kind of vibes. We have now techniques, algorithmic techniques to extract the vibe of a model. Is this model more friendly? Does it like to use examples more often? Does it use emojis or communicate emotion when it's trying to explain stuff? And these vibes could also be important in predicting human preference. And we're starting to see signal for that as well. As I said, I'm also, in addition to being at Berkeley, a co-founder at RunLLM. At RunLLM, we are building AI-powered sales engineers. And this means managing dialogue between engineering, support, users, handling challenging technical questions with grounded evidence. This means raising and tracking issues. And we have many services: Slack, Indocs integration, email, GitHub issues, IDs. It's insane that we're able to keep up with all these integrations, all these surfaces. And in building this product, we have to leverage a lot of the research. So we're leveraging data augmentation, fine-tuning, RAG, agentic reasoning. So it's nice is giving at least me some visibility into how Gen AI is, how it works when you put it in production. And one of the kind of cool early results is that we're seeing this same effect, that human alignment is critical. Because our models interact directly with customers, how a model answers is critical. It's more important than just being correct. So we want to have concise answers. We want to abstain from answering when we're uncertain. So we don't want rambling BS. We don't want speculative explanations. People want to know, is this the answer? Here's the answer. If not, I don't know, and maybe some references to look at. So we rely on LM judgments to evaluate our pipelines. So we are changing our models constantly, and the ability to use a rubric, the automated judgment process, allows us to try new things. So when a new model like O1 comes out, in a few hours, we can see if it makes an improvement in our customers' interactions. So we're in the age of conversational evaluation. This means organizations will use generative AI to interface with people and to accomplish open-ended tasks. And they need to evaluate these models not in exams, multi-choice questions like MMLU, but real application settings. So what should you be asking? What should you be thinking? One thing that I think everyone should start to ask themselves is, how can I evaluate the LLMs or the pipelines I'm building directly on my application? Can I start to define rubric, create examples of what a good or bad interaction or response might be, and then start to use LLMs to judge that process? And then in some cases, maybe even having this voting interface where people can provide additional signal. So how to collect the right information about how AI is working is critical to being agile and making progress in this space. So that is the age of conversational evaluation. Now I want to talk about synthetic data. So I think we are entering the age of synthetic data augmentation really, and this is really teaching models with data augmentation. So using models to augment our data to be able to train another model. So here's a simple picture of what that looks like. I have some original data. I have some clever prompts that let me interpret that data in interesting ways. I feed the prompts and the LM and the data to the LM, and I get some enriched data, which is a refined version of my original data that I can fine tune my LM to produce a new large language model, new LLM, that represents whatever behavior, whatever thing I was trying to teach it through this prompting process. This enables us to encode new behaviors and specialize our models for certain domains and certain kinds of data. So I want to highlight two projects that have touched on this. The first is the Gorilla project. Here we're studying the use of APIs as tools. So this project in itself has a pretty exciting thesis that the way we will interact with the web, with the vast services on the internet, may not be a web browser in the future, but instead might be an agent or a model. So we might talk with some model that then decides what to do against the entire web. And to do that, that model needs to be able to interact with the vast number of APIs in the web. And we explored techniques in fine-tuning and RAG to both discover and then execute calls against these APIs effectively. It's a pretty exciting project. It was ahead of its time in tool use as kind of an API framing. It got a lot of publicity. And out of that, the students launched some pretty exciting follow-on pieces of work. Open Functions is a collection of models that are fine-tuned to do this kind of task, so function calling against APIs. We've started exploring a secure execution environment, so if we're going to run code, we need to do so safely. We've launched a Berkeley function calling leaderboard, and it's in its third iteration recently, where we evaluate both, again, commercial and open source models and real-world settings function invocation. And then very, very recently, we started in Agent Arena to explore how tool use in a more general conversational context might work. The other project that touches on this synthetic data narrative was our work on RAFT. This is retrieval-aware fine-tuning. It's an enhanced way of doing RAG. So we're exploring how to fine-tune models for domain-specific RAG. Many organizations are using LLMs by retrieving documents, RAG, and stuffing those documents into the context to improve the ability of the LLM to reason about stuff in that domain. But if we know the documents in the retrieval process in advance, we can tune for that. And so we here explored a synthetic data augmentation strategy that transforms a collection of documents into fine-tuned data set that allows us to teach the model to ignore distracting documents and how to read the documents in the domain. And this is offered as part of Azure Studio and the meta training recipes. So another pretty exciting project. Now, what's kind of crazy about both these projects is fundamentally synthetic data is the method. The whole method is how we transform documentation into a synthetic fine-tuning data set. The actual fine-tuning itself is pretty straightforward. So the process we explored here is we could sample a document from the domain, the original collection of documents, take a snippet of that document and generate a question, generate an answer for that question while looking at that snippet, and even generate an explanation of why that's the correct answer, which we could then use to tune models to be more informative. And then we can construct a training data set by running this process repeatedly. This is a synthetic data set that we can fine-tune models on to have them perform better in the setting. This allows us to reframe existing data, reflect new tasks like RAG, and new behaviors like function calling. This is what enabled both Gorilla and RAFT. And this also allows us to emphasize important concepts in the data, how we sample the data, how we construct these questions, what prompts we use to identify what is a natural question for that domain, allows us to really shape the way the model both understands the data in that domain and how it interacts with the user. One of the weird corollaries of working on this project is we got to explore how to mix this idea of fine-tuning, augmenting my model with the more natural method of just retrieving and stuffing information in. And, coming into 2024, my bet at that point was at least what I hoped was the case was that fine-tuning was a method that we'd use only for augmenting the behavior of the model, and retrieval would be the core method for introducing new knowledge to the model. And unfortunately, I was wrong, and both these projects kind of proved me wrong. The early evidence is that fine-tuning is remarkably effective at incorporating both behavior and knowledge. And so if you're using these technologies and certainly using open models, you should really be exploring fine-tuning. So fine-tuning on synthetic data, this data that's been augmented from my original documents or my original APIs, is critical for getting improved behavior and knowledge. One last project in this space that's pretty exciting, a little bit adjacent from the fine-tuning story, is our work on TAG. This is table augmented generation. And the idea here is that if I want to do advanced analytics, it's often the case that I want to apply AI not just in how I go from a question to a SQL query, but even how I touch each piece of data. So I can augment my database by using LLMs inside the database to extract new piece of information from text or collections of columns. And then I can answer questions using SQL queries as my tool of computation, and then the LLM as a method of interpretation on those results. So that's a tag work. We have a QR code for it. Part of this has also been exploring how to scale batch inference. So if I want to run an LLM on millions of rows, I need to be far more efficient than we are today. And we've found new ways to reorder the data to take advantage of caching strategies inherent in most existing LLM technologies. All right, so we're in the age of synthetic data, and I think organizations will use generative AI to transform existing data sets into new synthetic training data sets. And this will enable the next generation of advanced analytics. It'll allow us to encode behavior and domain knowledge for fine-tuning, so both the tag work and the work on RAFT and Gorilla. And if you're working with data, and hopefully you are, you should be asking, how can I augment my existing data to capture desired behaviors or extract knowledge from it that I could then use to fine-tune the next generation of models? Now, a fun corollary of being in the age of synthetic data is we're probably also in the age of fine-tuning. And here, the theory is that organizations will create many fine-tuned versions of models to specialize in specific domains and behaviors. So this will enable smaller, cheaper, specialized LLMs to outperform larger generalist models. And we're starting to see this with both RAFT and Gorilla, where we can outperform GPT-4 on function calling and in-domain document reasoning tasks. So what should you be asking here? Are there subdomains which I could be fine-tuning on? I think RAG is a great example. If you're using LLMs to reason about documents, and it's documents that are unique to your business, you should be looking at things like RAFT, where I could try to tune my model to be able to really not only reason about documents effectively, but respond appropriately for the applications that you might have. All right, so I've talked about the age of synthetic data, data augmentation. Now I want to talk about the last kind of big bullet is the age of context management systems. And again, these are an emerging class of software systems designed to maintain a tidy context. You might be asking, what is the challenge of context? Why do I need a tidy context? Well, just to fill in some of the details, the context window is the space in which I can both read and write from for a large language model, an LLM. It used to be that we only had 2,000 tokens, 2,000 words-ish, in which we could express we could read from and write to. Today, models have gotten to about 128,000 tokens, which is an astronomical growth. It's very exciting. So we can put a lot of information in the context. But bear in mind, you need to put a lot of information to do many of the modern things. So you might have a system message describing the behavior and overall characteristics you want of the model. You have some tool descriptions of all the APIs that you want the model to potentially use if it's an agentic setting. You might have some reference documentation or things that the AI should attend to in answering questions. And you might have the prompt or dialogue that's ongoing with the user. And then you need some space to write your answer. So if you want the model to generate an essay, it needs space to write that essay as well. And that all has to fit in the 128 tokens of space. So the problem with long context, using even the 128,000 tokens that we already have, is that it's expensive. Computation scales quadratically as we move across the space. There are techniques that are being explored to reduce these costs, but fundamentally, state-of-the-art models have a pretty high cost for long context. The next problem is that even if you could afford the cost, you don't necessarily pay attention to everything equally. There's results showing that often information between the beginning and the end, the middle, is not as attended to. That when generating the output tokens, we tend to focus mostly on the prompt area and the system message area. Not all the context is used equally. And then even worse, if you put bad information, potentially distracting relevant but wrong documents in context, it will very quickly confuse the model. So models are sensitive to bad context. So we saw this early on with both the Gorilla and RAFT project. So in both these projects, we found that incorporating distracting documents during the training process, during the fine tuning, was critical to making them perform better at test time. Here, we were trying to address the sensitivity to distracting documents by tuning the model to be able to ignore them again during fine tuning. And we found this had a significant impact on the accuracy of the model. So here we're training the model to be more robust to a less tidy context. At RunLLM, we also experienced the same set of issues. And getting high quality answers really depended on the right context. So a big part of what we do with our pipelines, with the RAG work at RunLLM, is pre-processing and filtering before we even begin to index the data. We want to avoid retrieving bad information and feeding it to the model. And then when we go to retrieve the documents, we could stuff everything in context. We found that putting fewer documents, even re-ranking them, can have a big impact in overall accuracy. Finally, we've actually more recently found that using recursive retrieval, so retrieving documents, refining your query, and then retrieving again, and working with small collections of documents can even further improve the quality of the answer. So this idea of like repeated invocation with small, tidy context can make a big difference. But probably the project that most highlights the importance of tidy context is our work on MemGPT. So here, this project, we explored how to kind of more rigorously segment our context into parts that are, system instructions, things that the model can directly manage, a working context, and then a queue that represents the ongoing conversation, as well as an output buffer. And then here we're leveraging tool use to interact with external storage. So we're using external databases, allowing the model to both write to and read from that database into its working context. This kind of external paging is critical for allowing it to handle large amounts of information that can't fit in context, and using the power of retrieval systems like databases to index and find that information quickly. And in doing this, we leveraged ideas in operating system paging to enable essentially a virtual context that's infinite while using only a small physical context. So here we're working with just 8K tokens in this early work. So this generated a lot of hype. People are very excited about the idea of being able to work with an infinite context. And again, there's a real reason for this because there's a lot of information we'd like to be able to reason about with an LLM, and we can't, at that point in time, couldn't fit it. And even now, when we can fit large amounts of information, it's not always the best thing to do. One of the things that came out of this work is we started to think more about a broader sense of what is an agent and a platform to support agents. And so an LLM agent has to interact with the world, has to reason about its conversation, call tools. And a big part of that is managing the context. So early agent systems, and there are many, have generally not succeeded. One could argue they might have failed, partly because they often get derailed, distracted. They can't fully accomplish complex tasks. And our hypothesis is a lot of that is due to poor context management, that in interacting with the world, they build a very large context of distracting information. So our new kind of theory in my group on how to improve the ability of agents to solve complex things is really thinking about state management, both inside the LLM and externally. And so the key trick there is that in our interaction with the world, we need to be able to extract information from some database, some state, feed that into context so that the model can reason about just the right information. When it generates stuff, we need to then take the resulting output and store parts of it back into some external representation of state. And having a loop that manages this essentially serialization and deserialization of state into context is critical to making these agents work. And that's what the MemGPT project is doing. So I think we're in the age of agents. There's an emerging class of agentic systems that combine tool use with repeated element invocation to complete complex tasks. And here we're leveraging the problem decomposition that an agent has, so breaking things into steps and calling a sequence of tools to keep the context simple, to manage the context. And we're also incorporating tool use to manage interaction with the environment. And this can also include managing the context itself. So what should you be asking? Where could I break existing LM tasks, calls, into smaller, well-defined tasks with narrower contexts? And my colleagues at Berkeley have also been pushing this vision of compound AI. It's the same idea. If I can take a big complex task and break into smaller tasks, each of which uses a smaller amount of context, I'm likely to get much better results. All right, so I talked about 3 directions that are sort of inspired directly by the research that we're doing. And I think they will kind of inform how you might approach the use of generative AI and some of the opportunities for innovation. Now I want to step back and think about a vision for the future of the field as a whole. And I sort of see two big trends. So these are the 2 emerging fields. The first is around AI engineering. This is the study of the design and development and operation of AI-centric software systems. And the second that I think is pretty exciting is this kind of emerging AI psychology, the study of AI behavior and its interaction with human behavior. So the first is an engineering discipline, as it's in the name, and the second is a scientific discipline. And what I think is super cool is that they're really connected. That in order to build a sophisticated agent, we need to understand the biases and behavioral limitations of LLMs. And then as we build our understanding of these systems, that will inform our understanding of both the interaction with humans, the behavior of humans, and the underlying AIs. So these are two disciplines. I would say most of the research that we're doing at Berkeley has been focused on AI engineering. And I think a lot of the field is, the innovation, both in the tech world, again, in research, is around how do I build interesting things out of these AI building blocks. So in the process of doing this, I think we'll unlock new apps and functionality so that it's not the existing apps that will be made better, but we'll be able to do new kinds of things, like make software that you can reconfigure on the fly. So really cool opportunities. When I look at AI psychology, I think this is a newer, maybe even more exciting discipline that really the Chatbot Arena gave us our first window into what this might look like. And also we're kind of seeing some of this at RunLLM. So I already talked about some of the biases and stuff we saw at the Chatbot Arena. I want to conclude by talking briefly about some of the interesting things we're seeing at RunLLM. So one of the first things that I found that maybe the most exciting of all of these the things we've discovered in the psychology of AI is that people are honest, that when presented with an AI, they were willing to ask the embarrassing questions they wouldn't ask a person. And that's great for these kinds of technologies because we can help people get unstuck and resolve their confusions around the things that they were too afraid to talk about publicly. We've also found that people are impatient. And when we look at long responses on the arena, people generally like long responses, but when you're trying to solve a problem, being concise is critical. And so it's situation dependent, what makes a good answer, but we're finding that, in technical settings that being concise is critical. The other thing that kind of surprised me is that people are positive. We have an early product, it has rough edges, but 80% of the people are giving us thumbs up responses. So it's a pretty high positive response rate. And I think people are willing to accommodate some of the challenges in this technology, which is great. So we're going to see more adoption. But hopefully in the long run, we can maintain this positivity. People are friendly. We kind of, looking at some sample conversations, people don't use the kind of Google search of, I'm just going to put keywords in a text box and send it to the AI. They have a conversation with the AI. And that conversational behavior, that friendly behavior, seems to be both reflective in how people behave. And of course, we're also seeing evidence that may improve the model responses. So for me, on the company side, I think one of the bigger lessons learned here is that the good AI is a great user experience, and really nailing this kind of interaction, not just about accuracy, but the interaction with people is critical. All right, so I want to wrap up by saying, we're in an exciting world where, we have new emerging fields like AI engineering, AI psychology. There's a ton of really cool research coming out of Berkeley that I'm thrilled to be a part of. I put a link in this QR code for people to find out more about this research. You feel free to email me. And so I appreciate you all listening. Thank you all.